Hi everyone. Today's video is about VISVAP and VAP. This is the second episode. In the previous one we discussed the structure of the files and the connections to Vissim and what is VAP, what is VISVAP. In this one we will try to do a very simple program which is like a demand activated signal. This is our main line. This is our minor run. We will place a signal head here and here. We will place a detector here. And if there is no demand here, it will be green all the time. If a demand appears here, this goes to red and this goes to green. Then it goes back once the demand is gone. Okay, the reason I chose to do a very simple one, because in this one we can learn how to set up the PUA file, how to connect the files to Vissim, how to make the compilation or translation into a web file, how to load them, how to test, how to debug, and things like that. And then in the next video we will step up and do some like a network where we have like more than 2 arms, not just one demand actuation, but maybe extension, green extension and things like that. So just to create a bit of more complicated one. But please pay attention to every detail in this video because it is key to understand what's going on. I chose to do it step by step, and we will make mistakes, we will make errors, and I want to show how to fix them and what those errors mean. So first what we need to do is we create a signal controller, and this will be VAP. As you can see, two new the logic file and interstage file box appeared. So we need to create both files. Let's put it here like demand activated. It can be anything, it doesn't matter. Just leave everything by the default. Okay, let's create first the web control. We go and we need to create a PUA file. So the way to create a PUA file is you create a new file, test. And as you can see, we can see the text here. If you can't see the text there, you need to go to options, change folder and search options, view. And for you probably hide extensions for non-file types switched off. So you just, or switched on, so you need to switch it off. In this way, you can see the extension and then you can just update it. And yes, I want to change it. So this is the way it works. I have already set up a structure for the PUA file, so let's have a look at that. In the PUA file, you can add a lot of modules. These modules can be found in the doc manual I posted in the previous video, so just have a look at that, please. Let's start with the signal groups. So we will have two signal groups. We will have one for the main line. This will be A and this will be B. So we create an A and we create a B. So here you use a name and here you just put a number. IGM is integrity matrix. This is not something you must do. You can use and you can do, but we are not going to. It is not necessary. Let's keep things simple. Stages. First, let's add stage 1. So what is stage 1? Stage 1 is A. So in stage 1 we have A, and in stage 1 we have B. And one stage A is active, stage B will be inactive. So here goes B. We will have stage 2, that's gonna be B. And you can add like tab or space here, it doesn't matter. You can do the way you want. the syntax is not as strict. Starting stage, so these are all mandatory. Starting stage is stage 1, so it starts with A. Okay, so here for stage 2 we need to put red and A. So again, stage 1 is A, and in stage 1 B is red. In stage 2 B is green, A is red. Starting stage will be 1, so stage 1 will be A, and in stage 1 B will be red. What we need to define is now is the interstages. Interstages are transitions where you transition from one to another, and you only need to mark here, or you need to describe here the signal groups that change. You also need to add these. So let's go line by line. You put interstage in with $sign. This tells Vissim that this section is the interstage. And then we say interstage number 1. This will keep growing as many interstages as you have. The length, we don't know it yet, we will calculate it. From stage, I know that, so it will be a transition from 1 to 2, because we go from stage 1 to stage 2. 1 to 2. What is going to change? Which signal group? Signal group A or A will definitely change. Again, tabulated. And now we need to add 2 parameters. So we need to describe the change. If the signal group is already green, you need to say minus 127. Don't ask why. It is a rule. So if it is already green, it is minus 127. And you need to add here when it goes to red, relative to the interstage. So if the interstage is 10 seconds, in the 0th or the first second it will go red. I want this to go red immediately when the interstage starts. And what is the other signal group that changes? That's B. B is red, and here if it turns green we need to add when it is green. We need to add a little bit of intergreen here. So we didn't add like an intergreen matrix, so basically here we need to add for all of that. So the intergreen, let's say 6 seconds, let's put 6. So basically what happens, A is already green, so here is the green start, this is the red start. Minus 127 says to Vissim that it is already green, so there is no green start. And the rest start is 0, so when the interstage starts, when I say let's start the interstage, it will go red. B, green start, it is 6. And this includes any amber time or red amber, what you have, if that is applicable in your country. We can set these up in the settings later, I will show you, in case you need to set that up differently. Tab and red. When it is red after the interstage, or it's green, so there is no red start, that is 127. That's the code. So basically here I say that A starts at 0, the red, so A goes to red at 0 and B goes to green at 6. This minus 27, 127 and 127 is just basically the code to say that this is already green and this will be green. Just something to remember. And now we can fill out the interstage length. It can be 6 seconds because the green starts at 6, so we can stop it. However, the way I like to do it, and to simplify the logic we will write later in VISVAP, I add the minimum intergreen time, because when you call a signal, what happens is it is red, then it becomes green, and there is a minimum green time it needs to call. Usually it's 5, 6, 7 seconds, depending on countries, to make sure that if it goes to green, at least 1 or 2 vehicles can get through. So I'm going to add, let's say 6. So this way, when I call interstage from 1 to 2, then it will be 12 seconds long. In the 0 moment, so as long as it starts, A will go red, and B will become green, will change to green in 6, and we remain in interstage phase for another 6 seconds. We need to create more interstages because we have already created one where it goes from stage 1 to stage 2, but we also want to have an interstage when it goes back from stage 2 to stage 1. So what I do, copy and paste. You can leave out as many rows as you want. So this is gonna be interstage number 2. I'm going to give the length at 12. We will go from interstage 2 to interstage 1. And we only add here the signal groups that change. So what will happen to A? Let's delete these. So what happens at 2? So we are at stage 2. In stage 2, B is green. So B is green. B is already green, so it is minus 127. And B needs to go to red, so that's 0. If you pay attention, it's the same as here. So we could just basically copy paste this, paste it there, and just exchange this to B and put this to A. Because B is green already, so the start of green is green already, it's not applicable. So I put minus 127, and the start of red is 0. A, in stage 1, A is green, and I leave 6 second intergreen between the two. So that will be all red from 0 to 6. Then from 6, A will be green. Again, if you have an amber or red amber, that can be incorporated before that automatically. And 127 is the start of red. This code will tell Vissim that, the start of red is 127 because it is green. So it goes to green at 6 and it will remain green. And you need to put AND. Basically, that's it. That's the profile. So just set out the very basic details here. And the profile must be edited and created in Notepad. You can't really do in any software or anything. Notepad, Notepad++, any text editor, you need to create it. I save it. Now we go back to Vissim, double click on the signal controller, interstage file, and I put video poor. Now we need to create a logic file. The logic file, you need to have VISVAP. Again, I just created new and just saved it in the folder video as .visvap VV. Let's start from the beginning. You need to select on the left side of the screen the elements We will need to put a flowchart together to deal with the logic. On the right side, you can have parameters defined generally or for each program. You can set different programs for different peak hours. We are not going to worry about that now. You can have arrays, expressions. If you want to make things simple here, you can just put them here. I usually don't use that, but you can to make it a nice, cleaner logic here. So basically, you click on this. This is the terminal, so we start with that. Start. You can have statements, conditions, subroutines, phase separators, text, lines, and these arrows and stuff. Let's keep it simple. Here, we just start. We use stages, so we have a stage controlled plan. You can control signal groups separately, one by one, but I think that's an overkill for such a simple project. And also controlling stages are much simpler. So if you can achieve your control using stages, interstages, I would highly recommend just use them. If you have a very complicated controller, definitely then you need to go to and model every signal head separately. Then you don't need to have interstages in your profile, but you need to have like an intergreen preferably, because you can check for intergreen times in the logic. But let's not go that far, let's step back and start it. So where to start? Let's start with check if we are in a stage or not. You select it, you double click, and it creates a condition. So this is more like a question. You right click in it, go VAP functions. You can hear it is grouped into different groups. There are the stage one, and here there is a function called stage active. If you double click, it brings up here in this bottom window a little field where you see the brackets, and within the brackets you have this stage with the square brackets. Let's put stage 1, stage active 1. Let's close it. It writes it there. You can type it if you feel comfortable. You can say stage active 1. You can connect with the line. What you do, you select it, you click on the first one, and with control right click, you click where the arrow needs to go. So stage active, what it does is it starts. Is stage 1 active? If yes, it will go to the right. If no, it will go to the bottom. So if stage active is true, we need to ask a question. Is there a demand? How can we know that? Place a detector. So I'm going to place a detector here. Let me just make this a bit tighter. So I place a detector here. We can place long one, short one. In this simple example, let's just do this. Signal controller, you select the signal controller type. Standard is perfectly fine. There are other kinds. We are not going to use those. Pools, presents PT calling, we just use standard. Location there. That's fine, that automatically filled out. Activation or vehicle types. You can set it to any specific. Others, there are smoothing factors. You can read what they do. I wouldn't worry about these. Acoustic signals, you just don't deal with that. So just leave it standard, click OK. Oh, sorry, the most important thing is the port number. So this is the reference we will reference in VISVAP. This will reference this detector. That's 1. So what we will ask, is there a demand on detector 1? What we can do, go to the detector group. As you can see, there are lots of functions you can use. In this case, let's just take the simplest possible, which is like occupancy time. Occupancy time in seconds of detector and port number. Double click. We put it 1. So which means this will return the value of the time of the vehicle standing there. So if a vehicle has been on the detector for 5 seconds, this will have 5. Click OK. So occupancy, this is 5. Let's say we want to check it. So we need to use it as we need to make it into a question, basically. So we use say occupancy on 1 on the detector, is that greater than, I'm going to say 5 seconds, or just 5? If yes, what I want to do is that will mean that there is a demand on that approach. So I want to initiate the stage transition, the stage to go into 2. So I select statement, double click that, web functions. Let's have a look here. What do we have? Go to stage transition. Let's have a look. There is nothing there. Interstage. Starts on interstage. I think that's going to be fine for us. From stage to stage. So we already defined it in the pool file. Not in this one. So that from stage 1 to stage 2. So we are going to use that. Okay. So now basically what it does, starts interstage 1 and 2. If an interstage is active, stage active will not return to anything, it will say no. So stage 1 won't be active. So now we will be in a situation where an interstage is active 1 to 2, and that interstage will last for 12 seconds. So what we do now, we check for stage 2. Is stage 2 active? If yes, stage 2 is when it is green and that is red. So what I want to do, maybe what we can do, we can decrease the length of this. We will place the signal head here. So if there is a vehicle that will be parking on it. And now what we can do, just to keep our lives easy, we can create a very long detector here. Up there, covering that whole, maybe, I don't know, 20 meters or something like that, 25 meters. Checking if there is a vehicle on it. Because if there is a vehicle on it, there is demand. So I need to keep that green running. But of course, I don't want to keep the detector too long. So assuming that this link is like this big, and this minor arm is, so if let's say if I do that, that would mean if a vehicle is just on it here, I will still maintain that green and keep them red. And I don't want to do that. So what I want is to keep it as short as possible. Assuming that there is, a continuous flow of vehicles, then I keep it open for some time. We can block it, we will block it. But let's just keep it maybe this long, so it checks, if there is a vehicle close to the signal, then I wait for it and keep that green going. Let's do that. So that means I need to put a condition there. Occupancy for detector number 2. So we need to set a port number here, port number 2. So that will be our second detector. If the occupancy is greater than 0, meaning that there is a vehicle on it, I do nothing. If it is not greater than 0, meaning there is no vehicle on it, I want to go back to our original stage, our main stage. So to one interstage, which is this one. So we switch back A, the main line, to green, and we switch the minor arm to red. Okay, that's done. Let's squeeze a line here, because as you can see, automatically it added the arrows, which is incorrect. So what we do, we click on here and we use this insert row, and we select these and hit delete. Okay. Now connect them with lines. What I can do, I can just create a stop here. This is where it stops. And from start to stop, I hold Control and it connects everything. From occupancy, just going back to here, if stage 1 is active, so there are cars going here, and the occupancy is not greater than 5, so meaning there isn't a vehicle on the minor arm for at least 5 seconds, then I care nothing and just leave it like that. Nothing will happen. If I went to interstage, I also went back to the main. You always need to go back to the main flow, so just connect it there. Then it will check interstage 2 occupancy. What if there is no occupancy on the second detector? Then I go to interstage 1 back, and I connect it back to the main line. Let me just add another row here. And what happens if stage 2 active, so there is minor arm traffic going, and occupancy is greater than 0, so there is a demand. Then I again just go back to the main line. So I just connect it like that. So this works. I think we will try it now, and then we will improve it. We will add some more conditions to make sure that the minor arm or the other arm can't keep the lights on forever and not allowing green time for the other. But let's just save it. Let's go to compile, generate web file. At least one line of the cell is not completed. So probably it was just the remaining little arrow there. Let's try it again. Flowchart successfully checked. So in order to remove it, you saw what I did. I just clicked on there and just double clicked on it again, and then it removes the little arrow if you have such an issue. Okay, now we compiled it. We go back to Vissim, signal controller, and we edit, reference it here. Select it. Then it is ready to use. Let's just give it a try. Let's place signal heads. Okay, what we do, we haven't added the signal groups yet. So here I just add the 2. So we need to add the signal groups in Vissim. I just forgot it. So 1 was A, 2 was B, And we can add min green, red amber, min red, amber type. So this is the place where you can basically set up if you have like a red amber time of 2, or if you have an amber time of 3. Then Vissim will incorporate these into the VAP. We put it here into these times. Okay, let's just give it a try, and let's go from there. So this is A1. I place it just above the detector, just downstream of the detector. This is B. I save it. I haven't added traffic yet. Let's just see if it runs. Okay, it runs. Just since there is nothing tomorrow, it basically completed it in 2 seconds. Let's just add some vehicle inputs. This is the main. This is the minor. Let's put 300 to the main. Let's put 50 for the minor. Okay, let's just slow things down a bit. So it is green. Let's wait until a vehicle appears from the south. Then it goes back. Let's increase traffic a bit. What will happen? It goes back because the detector was short. But it keeps it open as long as there is a demand. Let me increase that detector a bit. So now what we will see happening is that the minor arm basically takes over the main arm, and it will be like, okay, let's increase that a bit more. The minor arm will basically become green forever. Still not enough traffic, can't believe. Okay, let's do it this way. So as long as there is a vehicle on the detector, that will remain green. What we want to do is we want to create like a condition that this shouldn't happen, so that to put an end to it. So we need to create an extra condition. So let's say when stage 1 is active, here we need to say occupancy is greater than 5, and we need to consider that the green time for the stage, for this, is not more than, let's say, 1 minute or 2 minutes. But since this is the main arm for us, we don't really worry about it, so it can be long as long as there is no demand here. And we will add this green time condition only for the second arm. Because we don't want this to switch, I want this main arm to be green as always, unless there is a demand from here. And if the demand here is non-stop, I still want this to stop occasionally after, let's say, 40 seconds, and to give this a minimum green time of at least 20 seconds. So let's just code that in. Let's code in first that the condition let's code in that condition. So if stage 2 is active and occupancy on the detector greater than 0, so there is a demand, and if there is no demand, then it goes back. But I want it to go back if the time, if it has been green for at least like 1 minute, let's say. So what we do is we hold down Control and hit Enter, and then we can create a new line. So we go to functions, we go to stage, and we select stage duration. Or, to keep things simpler, we just go to signal group and put green time. So we basically just say that T green 2, so 2 is signal group B or 2, so the minor arm, this, that is signal group 2. I just put it there. We need to create a condition from it, but let's just think it through. I want it to go to signal interstage if this is over. So if this is greater than, let's say, 60 seconds, or let me use a variable here, max time, and let me define here max time, and general value will be 60. And what we do, if occupancy is greater than 0, or max time is over, or sorry, the green time is over max time. So if occupancy, it is not correct, so it should be end and smaller. So if occupancy is greater than 0, so if there is a demand and the green time hasn't reached maximum, then I go out. Otherwise, either of this is true, so the demand drops or the green time exceeds max time, then I go to interstage and go back. And I think the syntax wants you to use brackets here. You need to compile it. Okay, let's go back to Vissim. Let's increase that flow again, just to be able to test it. So let's see the timer here. So vehicle appeared there, so it waits 5 seconds, and it is green. Now, it is green from around 24-25. It should have demand non-stop, but it should stop the signal at 25 plus 60, so around 86. Let's see. There you are. It is going back. And now the main line comes on. But as you see, it already goes back because what did we do? From 2 to 1, A goes to green at the 6th second. Interstage is 12 seconds long, so there was a 6-second green time. And VISVAP was already in stage 1, and the occupancy was greater, so it went back to stage 2 already again. So what we must do, we must to keep this a bit longer on. We want to check if there is a demand here first. Let's stop it. Let's put a detector here. Port number 3. So here we add another occupancy 3. So what do we need to do here? We only want it to go to interstage 2 if there is no demand here. So this, let's say, occupancy equals 0. So if there is a demand on the other one, if there is no demand on the main line, then it can only go to interstage 2. But what we need to consider, if there is a non-stop demand on this my major arm here. This will keep it on forever, even if there are vehicles waiting here. So we need to add a limit there as well, the same next time. So what we do is we also say end, Control Enter, brackets. So we say day green and the first signal group, so signal group A, and that is less than max time. So what it says, if there is demand on the minor, if there is no demand on the major, and the green time is over, so we need here an OR, because if there is demand on the minor and no demand for us, or this is true, that the time has passed, then it goes to interstage 2. So let's have a try, because I got a bit confused now. Let's see instead of think. It shows immediately if it's not right. So this should be on for 80, then it goes on and it's off. So we need to make sure that something is wrong here. So let's have a look. So there is something wrong here. So the occupancy, if there is demand there and occupancy free is 0. So here we need to add another bracket probably. Yeah. Let's just test that. No, it goes to there. It is still not doing it. Let's just think about it. So occupancy, there is demand there, and occupancy free is 0. Let's just check that detector, that is 3. What we can do is a good time to start debug mode. So we can select it, okay. If we run it, we can see here as Vissim is running. And here I have the controls. So we can go here, we need to select continuous, and we can run the model like this. It goes very fast, but if I go step by step and I put this to, so if I run it here, if I switch off the continuous, I can see where is it. And now I can go command by command. So as you can see, now it goes, let's stop at 80, all right. $85. I was too quick. Let's put it to 130. So it will stop 130. Now, let's just wait until it goes red again. Now, and let's see what happens. I switch this off. It is now green, so stage 1 is active. So I put play, and now I can control the simulation from VISVAP. I use next step in. Next command. It is acting strange. Okay, I need to stop it because it seems the connection got, yeah, probably VISVAP got crashed or something. So typical. Let's just try, maybe it will resolve the problem. Okay, I'm going to switch off the debug because it's quite buggy. Let's just do a run. Okay, it seems the tool just crashed. So I am going to close VISVAP and restart it. Okay. Let's try it again. Hopefully Vissim will carry on. I don't need to reopen it again. So let's start. No, it doesn't work. I restarted and cut it out from the video. Okay, welcome back. Sorry for this. It just shows you that sometimes these happen when you try to debug it. What you need to do basically, just need to restart VSWAP and unfortunately Vissim as well. So let's have a look. So what happens is, if we just think this through, we will see how retarded I am, because this should be the other way around. So when this is true, then we go and change the interstage. So what that means is, if the green time for the signal group is over 60 seconds, then we need to go and change it. So let's compile and let's have a look. It keeps it green as long as it needs to be green. Like that. Thanks for watching the video. As you can see, I try to do it from scratch, non-scripted, so you see it the way it is. I hope this troubleshooting helps you on your project when you face issues, errors, any problems. It's usually so tiny as this, and the brackets and things like that. So thanks a lot for watching. I will make a next one, which we will add more stages and more complicated stuff. Please comment and let me know your thoughts and your recommendations, or what would you like to see. And please like and subscribe. I would appreciate it. Thanks a lot for watching. Bye.